All right, so let's start chapter 8. So chapter 8 is titled Introduction to Solutions and Aqueous Reactions. So this chapter we're going to focus on if I have a mixture. And specifically we're going to talk about kind of homogeneous mixtures in this chapter. And how would I do reaction with those? How would I do limiting reactants? Or just kind of figure out anything with them, okay? So that's going to be the focus on our chapter. So first let's talk about, well, what are solutions? So I kind of already hinted at this. So solutions are homogeneous mixtures. Homogeneous mixtures, okay? Now, remember, let's refresh. Homogeneous means it's the same throughout. So you can kind of think about if I had salt water would be a homogeneous mixture, unless you added too much salt, settled at the bottom. Sweet tea is a homogeneous mixture. Anything where it's uniform throughout, compared to like a heterogeneous mixture where it would be like sand and water, where the sand was settled at the bottom. So homogeneous mixtures. So in a mixture, in a solution, we're gonna have two parts. Two parts in our solution. The first is the solute. This is the component of the solution that changes state. So the component of the solution that changes state. The second part of my solution is the solvent. The solvent is the component of the solution that keeps its state. So one is going to change states, one is going to keep its state. Now, sometimes you might mix two things that are in the same state. So you might mix two liquids together, and then the solute would be the component that you had less of. So if they end up being in the same state, then the solute is just the one you have less of. All right, so let's think of an example. So if my example was salt water, what are the two components? I would have my salt, and I would have my water. So which one would be changing state? So to make salt water, you would usually take your solid salt and dump it into the water and mix it up. So the water stays as water before, and now it's just still, as liquid before, and now it's still a liquid. The salt, however, is going to go from a solid to now being dissolved in my water, which is aqueous. So the salt would be the solute, the water would be the solvent, and the salt water would be the solution. Okay, now if I want to talk about solutions, I can talk about how concentrated they are. And so when I talk about something's concentration, I'm talking about the amount of solute. So concentration is the relative amount of solute in the solution. So you can talk about, well, what's the concentration of my salt water? So I want to know about the amount of solute in the solution. And I could talk about it in terms of, is it really salty water, or is it just a little bit of salty water? So we could talk about it in like a qualitative sense. So in this case, we could talk about dilute solutions and concentrated solutions. So dilute solutions, they're going to have a small amount of solute in the solvent. Concentrated is going to have a lot of solute in the solvent. So if I have really, really salty water, that would be a concentrated solution. And if I had kind of salty water, maybe brackish water, if you're familiar with that term, then that would be a dilute solution. You can think about like really strong Kool-Aid, or Kool-Aid that is just like pretty much water with a hint of like whatever flavor you put in, grape or cherry or fruit punch or whatever. So dilute solutions have a small amount of solute compared to solvent, whereas concentrated solutions have a large amount of solute compared to solvent. Okay? So that is how I can talk about the concentration, but this is very qualitative. I'm just saying, is it very concentrated or is it just a little concentrated? But what if I wanted to get a numerical amount that kind of represents that relationship of how much solute is in this solution? So instead of it being qualitative, I can actually find a quantitative measurement. So my quantitative measurement would be the molarity. Molarity. And so the molarity is the moles of solute per 1 liter of solution. So it's going to give me kind of like a ratio, a relationship of the solute to my solution, but we're going to talk about moles instead of grams because I want to put it in a unit that's not mass dependent and takes into account the mass of each of those atoms. So moles, and then I want to be based on how much, the volume, because I'm talking about a solution, and so now I'm going to start talking about it in volume units. So if I want to calculate the molarity, the unit for molarity is a big M, okay? So if mass was like a little m, volume is a big V, molarity is a big M. And so the way that we would calculate this is it's the amount of solute in moles divided by the amount of solution in liters. So you get big M is equal to moles over liters. It's kind of the shorthand for that. So we can talk about the molarity of a solution. One of the ways we could talk about it is kind of seeing how would we make a certain molarity. So here's kind of an example, and say I wanted to make a 1 molar, and so, let's see if it had it on there. Nope, okay, it's fine. So instead of saying molarity, if I wanted to say it in a shortened, it's molar. So 1 molar, instead of like moles and mole, liters, liter, or L, there's a shorter way of saying molarity. Okay, so I want a 1 molar NaCl solution. So what I do is I want to say, okay, well, but if I'm going to be 1 liter, so to have 1 molar, then it's got to be 1 moles over 1 liter. So I need 1 moles of NaCl, which I can calculate the grams of that, because I know how to go from moles to grams. So I can calculate the grams of my NaCl, and I can weigh it out. So I weigh it out, and I put it into my container here, my volumetric flask. So I weigh out 1 mole of NaCl, and then I add the water up to my 1 liter mark. And then I mix it up, and then I have a 1 molar concentration of NaCl. So this is how I could make a solution at a very specific concentration. And you always want to add your solid first, then before your water, because remember, if you add the solid after, the water level will go up. So then you might go over the line if you didn't measure it correctly. Okay? But we want to be able to calculate the molarity. So we have an equation here, and you kind of talked about how I can make a solution, but we want to talk about being able to actually calculate the molarity in parts of it. So in the next lecture, we're going to do a problem on calculating the molarity.